Tonight you came to learn some answers to some scientific problems. And full disclosure here is I'm a big proponent in the freedom to think. And to think you need all the information so you can come to your own conclusions. But sometimes we don't get all the information. And so our conclusions are kind of skewed in a certain direction. It's like that saying, beware of one hand clapping. You know, there's two sides to every story. But if you're only hearing one side over and over and over again, chances are the opposing view is being censored by those in authority. So you've got to watch out for that. And I agree wholeheartedly with Dr. Thomas Chamberlain. He lived 100-some years ago, and he was former president of the University of Wisconsin and the first head of geology department at the University of Chicago. He was the president of the Chicago Academy of Sciences. So he's one of the sharpest tools in the box. And he wrote a famous paper, and he warned researchers not to let one hypothesis dominate their thinking. Instead, they should always have or seek multiple working hypotheses. Then they can sharpen their analytical skills, they can compare and contrast, and they can think critically and independently. Because if you only have one dominant theory, people just memorize and conform. And I brought this up, a professor here at St. Cloud State a few years ago, before COVID, and I told her about this, and she said, well, that's not how we do science. And I wish I would have asked her, well, how do you do science? And I'm concerned that they do it by consensus. You know, science isn't consensus, and if it's consensus, it isn't science. And that's why I'm very, very concerned when I hear somebody like Neil deGrasse Tyson talking about consensus, because that is not how science is done. The people we remember in science are people who broke away from consensus. But listen to what he says, and keep in mind, he's got a pretty big microphone. A lot of people listen to him.
This is world-renowned astrophysicist Neil deGrasse Tyson, a scientist, explaining why you and everybody out there shouldn't ask questions. Watch.
There's a list of top-ranking medical professionals. Just take a look.
I'm talking about, excuse me,
Dr. Peter McCullough. No, I want to go through what happened
consensus.
Here. This is the problem with the consensus.
The consensus.
Okay,
medical professional.
I want you to
because the medical is so huge. I can find you an astrophysicist who is sure we've been visited by aliens.
The problem was the scientific method died here, and this is the point I want to make. It died a death here, and I need you to help me save it, because Dr. Peter McCullough is the leading cardiologist.
I don't care if titles don't matter here.
But what should matter?
They don't matter.
What
matters
should matter?
Is the consensus. I'm not interested in medical pedigree. I'm interested in medical consensus, in scientific consensus.
Scientists that were on the ground, that were dealing with patients, were being censored, were being shut down. Their YouTube channels were being shut down. Their LinkedIns were being shut down.
Because the individual scientist does not matter.
So let me get this straight. The scientist doesn't want you to follow the scientific method because it goes against the scientific consensus, even if the consensus was wrong.
Even if the consensus, well, has the consensus been wrong? Absolutely the consensus has been wrong. And they taught geocentric universe for over 1,000 years. That's where the Earth is the middle and everything revolves around it. And it took people to stand up to the consensus, like Copernicus and Galileo and Kepler and Newton, to stand up to consensus and give another explanation so that geocentric theory could get thrown on the scrap heap of history where it belongs. Also spontaneous generation, they taught that for thousands of years. Life just pops into existence. If you want to make maggots, just put meat on the counter. If you want to make mice, just put some rags and grain in the corner. Life just pops into existence. And it took Louis Pasteur in 1859, by the way, that's the same year that Darwin brought had his natural selection, his book get published. And he put up some experiments and he proved that spontaneous generation was wrong. Life only comes from life. And he was a big opponent to Darwin. He did not agree with that. And also uniformitarianism. That's where you can only use present processes to explain past events. And it was J. Harlan Brents in 1923 where he explained the Washington Scablands with a catastrophic glacier flood. But that went against the consensus that everybody ridiculed and mocked him. But it took decades, and he was actually right. And there was consensus about vestigial organs and junk DNA, and those were science stoppers for a long time until people figured out, no, there's reasons for this. But I think the most embarrassing one of them all is in the consensus is Ignaz Semmelweis. He was a medical pioneer persecuted for telling the truth. So what truth did he figure out? Hey guys, wash your hands after doing an autopsy. Something as basic as that. Because he figured out that the death rate in the hospital for birthing mothers, it was a lot higher in one wing than the other wing. And he figured out, well, what's the difference? Well, in one wing, you got the nurses delivering babies, and on the other wing, you got doctors. And what were the doctors doing before they delivered the babies? They were doing autopsies on the mothers who died the day before, and they went from the dissecting room to the birthing room without washing their hands. And it just seemed so embarrassing that, and he had the data. This is 1847. He said, wash your hands, scrub your fingernails with chlorine. And yet he was rejected and ridiculed by those older contemporaries. He was going up against consensus, and thank God he did, but they never gave him the credit he deserved, even when he had the data. He was running a hospital and he had a 1% death rate for mothers. There was other hospitals, they had a 10 to 15% death rate. And yet they mocked him. They said it was time to stop the nonsense about chlorine hand wash. And it's very, very embarrassing for the medical profession and for the scientific profession. And it may be embarrassing today. What are we believing today that people look back at as embarrassing? And they even came up with the Semmelweis reflex. That's where long-held ideas can remain entrenched despite potent evidence to the contrary, and people can and do persecute those who challenge the consensus, even when the consensus is wrong. Even when it's wrong. And so the medical profession, they had a pretty embarrassing time back then. But again, I think they had a pretty embarrassing time lately, too. This is a book by Pierre Corey. It's called The War on Ivermectin. And in here he says that maybe 10% of the doctors he knows can think critically. The rest of them just want to follow procedures and guidelines and policies, even if it's not working. He said, and he said 10% was generous, but that's another talk for another time. But they were wrong. So how do you get a consensus so entrenched? Well, it's the only thing you fund. This is cosmologystatement.org back in 2004. It was an open letter to the scientific community and the new scientists. And the Big Bang today relies on a growing number of hypothetical entities, things that we have never observed. Inflation, dark matter, and dark energy are the most prominent examples. Without them, there would be a fatal contradiction between the observations made by astronomers and the predictions of the Big Bang theory. So how come it's still being promoted so much? It goes on to say, today virtually all financial and experimental resources in cosmology are devoted to Big Bang studies. Funding comes from only a few sources, and all the peer review committees that control them are dominated by supporters of the Big Bang. As a result, the dominance of the Big Bang within the field has become self-sustaining, irrespective of the scientific validity of the theory. And there are other theories out there, the plasma theory, the Setterfield theory, and they seem to be getting a lot better results, but there's no funding for it. And so that's how something gets so entrenched. And the Big Bang is becoming a laughingstock. This is Jason Lisle. And he did a talk on Creation Sante. You can see it. And he said, you know what? They got this James Webb telescope. They're going to look so far out there, they're going to think they're going to see galaxies being formed because they're looking so far back in time, they think. And he says, he predicted that they're going to be wrong about what they find out. And then he said, when they're wrong, I predict that they say that galaxies formed much earlier than normal, or much sooner than normal. And he was right both times. It discovered that he predicted they'd say Webb discovers that galaxies formed much earlier than previously thought. That was his prediction after they found out they were wrong. And that's exactly what they said. Galaxies started forming much earlier than many astronomers previously thought. And there's an article from Scientific American. James Webb Space Telescope, first glimpse of early galaxy could break cosmology. Is it a mirage or a revolution? And it talks about everyone was freaking out because they didn't find what they were expecting to find. In the weeks and months following the JWST's findings and surprisingly mature early galaxies, blindsided theorists and observers alike and have been scrambling to explain them. So it really is not a very good theory if what they find, it just astounds them. At stake is nothing less than our very understanding of how the orderly universe, as we know it, emerged from the primordial chaos. And then here it is. Maybe there's something happening in the early universe that means it's easier for some galaxies to form stars. So the Big Bang is having a hard time. And it's the same thing with when they had the Hubble Space Deep Field image, the Hubble image. They were expecting to find these infant galaxies. And Bob Enyart from Real Science Radio says, you're not going to find that. You're going to find average, everyday, normal galaxies way back there. And he was right. Again, when there's just the bad perspective of the past, so they aren't making accurate predictions. And there's another theory out there called the hydroplate theory. And we had this poster. It was going to be an online conference. It had never happened before, and it was going to answer all these questions. The origin of the Grand Canyon, nerves and dinosaur bones, fusing past iron, plateau formation, cubonite in comets, which can only be formed in scalding hot water, frozen standing mammoth, peanut-shaped asteroids, rounded boulders in Comet 67P, rock from Earth on the moon, and carbon-14 and fossils, coal and diamonds, and shells on Mount Everest. And so we had this poster up there. It was going to be an online conference. We thought, wouldn't people want to know the answers to these scientific problems? I would think they'd be banging down the doors. I went into the science departments, and I said, hey, you guys might want to listen to this. Watch these guys. There's PhD guys who are going to be talking. And I even went into President Wacker's office and said, this is a good theory. You should probably check it out. She didn't have time for me. But I saw her later that day as I was in Atwood, and she had time to talk to the students, but she didn't have time to talk to me. And I've got a theory that's going to explain all these problems. And I even talked to her in the past. It was like, you know, you might be able to attract more students if you would allow a diversity of thought in the science class. And she seems to be for that. But when I go into the science departments, they don't seem to be for that. But why do I have so much confidence in this theory? Because we got PhDs talking about it, banging this drum. There was 3 of them that spoke at the conference. And there were some other excellent, excellent talks. And one of them is a professor of aeronautics at the U.S. Air Force Academy. And he's banging this hydroplate drum. He says, this is the theory that makes the most sense. And he's the one that published those trans-Neptune object papers. And so he really has a grasp of this. And he's really thinking, this is the theory. So we had those posters up at St. Cloud State, and somebody stole one. So I put it up again, and somebody stole it again. And the other thing, you know, I love the freedom to think, and I hate censorship because that limits the freedom to think. And so we did the talk at our local creation club here in Sauk Rapids. And we had 50 flyers like this printed up. And we put them all over St. Cloud State. And we put a header on it. It said, see what a poster thief wants to censor at SCSU. And then we're actually doing it here again tonight. And if you can only listen to one talk on that hydroplate conference, you can go into Rumble, and it's called the Hydroplate Conference, or you can go into YouTube, search Hydroplate Channel, or else hydroplate.org. You'll get to find them all. All the talks are online. And watch the Comet talk. At the 22-minute mark and the 31-minute mark, you're going to listen to Kevin Lee, who stood face-to-face with a NASA scientist in charge of getting the stuff back from the comet to Earth. It's called the Stardust mission. And he stood face-to-face with them, and to paraphrase, he said, you're going to find stuff from the Earth in that comet. And that professor, or that scientist, Dr. Brownlee, says, no, we're going to find stuff from the Oort cloud. And he was shocked and dismayed to find stuff from Earth in that comet. And then 6 years ago, Kevin Lee emailed that same scientist, and he talked about the DART mission. They wanted to redirect an asteroid. He reminded them about the accurate predictions that he had about the comet, so they know the guy has credibility. But then he went on to say that any plan to deflect the asteroid will have to be based on the assumption about the composition of the asteroid. The physics behind the chosen plan may work for one composition, a solid rock, but fail if the asteroid consists of a loosely held together rock pile, which is what the hydroplate would predict. And guess what happened this year? There was a big press release. NASA accidentally causes Dimorphos boulder swarm as deadly as Hiroshima during DART mission. And this is August 9th of this year. And it goes on to say that space rocks have the same speed as the targeted asteroids. They are as dangerous. And it said there was unforeseen implications. No, there were foreseen implications, but they were ignored. I don't know what Dr. Brownlee did with that email, but it didn't get up the flagpole for them to reconsider it. And so what's happening now? We got 37 rocks coming at us now. Some are 22 feet wide. And it goes on to say that a 15-foot asteroid striking the Earth would produce as much energy compared to the same atomic bomb detonated on the city of Japan during World War II. So I don't know if that's true or not, or if that's alarmism. You know, maybe it's going to burn up in the atmosphere. I don't know. But what I do know is NASA made a catastrophic blunder because their perspective of the past, based on blind chance and random collisions of atoms, is wrong. And there is a theory that makes incredible, incredible predictions. It's called the hydroplate theory. And this is the theory, probably 300 pages. And it answers a lot of stuff they can't answer, like the mid-oceanic ridge and submarine canyons and Grand Canyon and Greenland Canyon and lakes under Antarctica, and it's just ice age and petrified trees. It goes on and on and on. This one theory ties together all those unanswered questions. And this book, you go into Amazon, $279. And it used to be a $30 book on Real Science Radio, but it's out of print. So now it's $279, and that's a sign of a good book. I got a couple of books here at St. Cloud State. It was like 130 for one and 85 for the other one, and I went to sell them back at the end of the quarter because I wanted to know what the kids were being taught. And they'd give me $10 for one and nothing for the other. That's a sign of that was a bad investment. But I still got those books so I can show people what people, and I see kids' mouths drop when they see that's how they explain life somehow. But anyhow, the theory was started by Dr. Walt Brown. He went to West Point. So he's a go-getter. He was an Army Ranger, paratrooper, and he got his PhD from MIT in mechanical engineering. So he's really sharp. And he was running the Benet Military Lab where he had dozens of PhDs and hundreds of scientists working for him. So he's about as sharp as they come. And he was going through South Dakota one time. And he heard on the radio, but this is back in the 70s, that somebody claimed they found an ark on a mountain. Noah's Ark on the mountain. And he's an evolutionist. He said, that's crazy. You know, there's no way. But going through, anybody drove through South Dakota? All you can do is count down the wall drug miles until you get there. And I think for a mental exercise that just humored him and said, okay, if there was a flood, an ark on a mountain, that means the whole world was covered with water. And that means a whole bunch of plants and animals got buried in mud and turned into fossils. He thought, wait a minute. If fossils are a sign of a flood, where's the evidence for evolution? And he began to ask his colleagues, you know, those really sharp PhD stuff. And after 2 years of asking them, what evidence do you have for evolution? They didn't have any. And he came up with this theory. And it's called the hydroplate theory. There's Walt Brown on the left and Bob Enyart on the right. And they're both my heroes. And Bob Enyart, he used to have Real Science Friday, or Real Science Radio. Every Friday he had a science show. And just go into rsr.org and search Walt Brown. And you'll get to listen to those two guys talk. And it just colors in all the details. That was a pivotal point in my life. Because then I've never seen the world the same or the solar system the same again. Because I can explain what's happening with the hydroplate theory. And I was at St. Cloud State a few years ago, and I was in the science department, and I met somebody with a geology background, a professor, and I said, you don't have a theory for Grand Canyon. And they don't. Because my brother-in-law, he had a class here, they're trying to figure out how Grand Canyon formed, and they spent a week on it, and there's probably 9 or 10 theories, and none of them work. And then on Friday, the professor said, you know, there's one theory we haven't talked about. Anybody know what it is? Kid raised his hand and said, Noah's flood. Professor said, you're right, but we can't talk about it. And that's not freedom to think, that's censoring ideas. And the Grand Canyon didn't form right after the flood. There's another talk on that, but there is this theory explains it. But I gave it to that professor because I know she doesn't have a theory for Grand Canyon. I said, this has a theory for Grand Canyon, and I opened up to the page and I said, would you like to look at it? And to her credit, she said, yeah. And she had the book for maybe 6 months, and we talked for about an hour and a half later. And she said, if the assumption is true, the science works. She just didn't believe the assumption was true. So what I'm showing you works. She just didn't believe the assumption. Okay, and so what is the assumption? So, you know, with theories, usually you take a look at what we have, what's the effect, and try and figure out what caused it. What caused the effect? And we never really have all the information. We can't go back in time to see it. This is different. It sets up the cause with one assumption, lets the laws of physics go at it, and it matches the effects perfectly on Earth and in the solar system. So what is that one assumption? Basically, half of the water in the ocean was inside the Earth. So just think of the Earth as a big apple. The skin is 60 miles thick, made of granite, and underneath that is a layer of water a mile thick, and under that is basalt. And the granite and basalt are touching each other at certain places. So you got these interconnected water chambers inside the Earth. That's the only assumption. How it got there is not part of the theory, but that's the starting point. And then you throw the laws of physics in there, you throw the moon in there. Moon tugs on the Earth, has high tide and low tide twice a day, tugs on the Earth, so it's going to stretch the crust. And back then, the crust wasn't broken into plates like it is today. It was just the crust. So it'd stretch and compress, stretch and compress, stretch and compress, and that generates heat. Heat has to go somewhere. It goes into the water. Water gets hotter and hotter and hotter. It wants to boil, but it can't because there's no room to expand. And it becomes at 705 degrees and 3,200 pounds per square inch, supercritical water. And they've known about this for 100 years, but it's not very well taught. It's not taught a whole lot. So a lot of people have never heard of it. But supercritical water, where it's not really water and it's not really steam, but whatever it is, it dissolves things like crazy. So it's dissolving the granite above and the basalt below, and it's making stuff like calcium carbonate and silicon dioxide and sodium chloride, which are just fancy words for limestone and chalk and quartz and salt. And keep in mind, whenever limestone forms, it releases an element of carbon dioxide. And there's 60,000 times more limestone on the surface of the earth than carbon dioxide. And Walt Brown, he used to have lunch once a week, or he'd talk with this guy once a week, Bob Dietz, I think his name was. And he's the guy, I think he coined the word seafloor spreading. And Walt asked him, hey, where'd all the limestone come from? And Bob says, beats the blank out of me. Where did that all come from? But this explains it. The carbon dioxide just got recycled in those chemical formations and breaking down. And so you get all this limestone and minerals underneath there, and the crust is getting weaker and weaker, hotter and hotter, more and more pressure. Walt Brown says there was 372,000 pounds of pressure in that subterranean water chamber. And finally, the crust just gave way. There was a crack, and it erupted, and the water just went from 372,000 psi to what, 14 pounds per square inch at sea level? It just exploded out of there with tremendous force, and water shot up like crazy, and it ripped the earth in two directions. It ripped the crust of the earth in two directions. It went all the way around the earth, and it came together on itself, and it could rain for 40 days and 40 nights, like the Bible says. You know, the hydraulic system we have today, you can't rain for 40 days and 40 nights. But this is a fountain coming up. And people say, well, if that happened, wouldn't it leave a mark? And the answer is yeah. It left the mid-oceanic ridge. That's that ridge that's at the bottom of all the oceans and comes together on, like a seam on a baseball. Walt Brown thinks it came together at the end, at that circle there, and then it just shot up from there. So he runs the movie backwards and thinks it started over there. And so it just ripped the crust going like 2 or 3 miles in a second and got around the earth in like 2 or 3 hours. And then the water's just shooting up like crazy. And that's how you get the sediment. I always wondered, where did all this sediment come from for the sedimentary rocks, which are a mile deep, average, on all the continents? Where did all this sediment come from? Well, it's the granite getting eroded. It's getting eroded on the side and on the bottom there, and then the basalt is getting eroded on the top. And it's very interesting. If you get sedimentary rock that doesn't have carbon in it, like limestone, the ratio is 65 parts granite and 35 parts basalt. Well, that's because I think the granite was getting eroded in 2 places, where basalt was only getting eroded in 1. And all this stuff is crumbling down. So now you got 2 60-mile cliffs, and on Earth you can only have a cliff 5 miles high before it crushes the rock below. And you got two cliffs that are 60 miles high, so they're crumbling into this supersonic water, just getting crumbled, and that's how you get the layers all around the Earth. Anybody ever been to Grand Canyon? Those layers don't just stop there. Those go all across the continent. And this is from Is Genesis History, which is a pretty good one. That Zuni mega sequence, it goes all around the world. Tim Clary's done some research on that. So these are worldwide layers of sedimentary rock that had to be laid down all at once. That screams loudly for a worldwide flood. If Randy Galuza was in college, he'd ask his professor, hey, what present process today is laying sediment down worldwide? It's not happening. It's not happening. And so again, there's the mid-oceanic ridge. And if you go into the Wick Science Building in the basement by their astronomy thing, you can see the ocean. You can see the map of the ocean, and you notice there's straight line cracks there. Those are tension cracks. See, when the rock is getting stretched in 2 directions, or getting stretched, when it'll break, and then it'll just be a nice straight line. And if you notice it's being stretched in 2 directions, sideways and up and down. How are you going to form a mountain range all around the world by stretching it in 2 directions? But anyhow, so now you got 2 60-mile cliffs. They're getting farther and farther apart, and eventually there's nothing pushing down on it. Walt Brown doesn't think that the Atlantic Ocean was there. And so there's nothing pushing down on it, and the mantle bulges. It'd be like lifting up a railroad track and the train starts to roll. That's what happened with the continents. So now you got North America and South America sliding to the west, and Africa and Europe sliding to the east, and they keep going until they meet resistance. And then the mountains form up. And the mountains buckle up. North America, I think, slid over the mid-oceanic ridge because the Rockies are twice as wide as the Andes. And I think that's why it slid over that. And you also notice that the mountains are parallel to the mid-oceanic ridge, the mid-Atlantic ridge. And that would explain that also. They're sliding, and then they met resistance, and then it got really hot and a lot of pressure, and the mountains buckled up, and this is how we get, with that extreme compression and heat, that formed our coal and our oil deposits. It also made metamorphic rock, where marble is limestone in heat and pressure, and diamonds are coal in heat and pressure. And that's where you got all that force to make that. And now we even find carbon-14 in all those things. And carbon-14 can't last 100,000 years. I've heard some people say 50,000 years. So that means all that stuff is less than 100,000 years old. And they'll say, well, it's contaminated. Yeah, well, it doesn't matter which layer of coal seam you take, how deep in the geologic column, it all's got the same, but pretty much the same amount of carbon. It should be random if it was all contaminated. And how do you contaminate a diamond, which is the world's hardest naturally occurring substance? And these are mountains in British Columbia. They just got folded like an accordion. They just got pushed together. And they had to get pushed together when they're soft. Otherwise, they're going to break. But they aren't broken. They're soft. They got pushed together. And you can do a science experiment at home. Just bend your finest piece of china. It's not going to work. So this had to be soft when it got pushed together. And this is Gunnison Canyon. For scale, on top of that canyon are 15-foot trees. So this is a huge, huge canyon. And those are not tension cracks. Those are not straight. These are compression cracks. They got pushed together. What's going to have enough force to to cause something like that to crush like that? Well, I would say it's the continents coming to a screeching halt. And you'll find the same pattern in the inner gorge in Grand Canyon. The basement rock of Grand Canyon has those same type of cracks. So how does that happen? As the continents are sliding, they meet resistance, they bulge up, and you're going to get those cracks. But then those slanted layers are going to get sheared off by the layers that are still going straight across. And that's how you get slanted layers underneath the flat layers in the Grand Canyon. And they have a hard time explaining that with blind chance and random collisions of atoms. And this is very interesting. This is an anomaly that this theory explains, but they don't even put it on the website for Grand Canyon. This rock is not there. This is a quartzite rock that got formed and it got lifted up in that flow of sediment. And there it is. It's by Isis Temple, and it is a 5 to 10 ton rock. I don't know if you can see it there in the middle, but it came from the bottom right. It was formed on the bottom right and it got lifted up into sedimentary rock. How's that going to happen? Well, this hydroplate theory explains it. And these are the coordinates, 36 by 112, and those are Walt Brown's grandsons. And again, when you look at that rock, it just kind of the mud gently forms around it. Okay, and so you got these mountains rising up. That's a big mass on a small base, so those mountains are going to sink in. And that's going to cause the plateaus to form. And this talks about the plateau mystery. What mechanism would cause a large volume of low-standing continents to rise rapidly a mile in the air? We have a double-sided mystery, for the Colorado Plateau seems to have grown downward at the same time that its emerged part rose upward. So this is a huge problem for the secular geologists. For the blind chance and random collisions of atoms, they can't explain it. But this does. What's the mechanism? It's hydraulic lifting. What's the force? Gravity. You got the big mountain squishing down on that magma. The magma shoots out to the side, and then where it's weak, it block faults up. Hydraulics. That's how the plateaus formed. And some of the lava goes up the crack and gets on top of the sediment, and it's going to get hard up there. And then when if there's a whole bunch of water, like the Great Denudation, it's going to wash away not the lava on top, but it's going to wash away the softer sediment, and you're going to get something like Red Butte. This is 1,000 feet of sediment with lava on top, and this theory explains it perfectly. And notice how close it is to Grand Canyon. That was the Great Denudation. 2,000 cubic miles had to get removed, scraped off the top before the Grand Canyon could even start to get cut. And this explains it perfectly. And then again, with the mid-oceanic ridge rising up around the world, something has to sink in, and that would be the Pacific Ocean. Okay, the Pacific Ocean got sucked in at the Ring of Fire. That's why the Pacific Ocean is so much different. That's why the trenches are mainly in the Pacific Ocean. That's why the Mariana Trench is there. The Mariana Trench is deeper than Mount Everest is high, but it got sucked in. And there's like 40,000 volcanoes down on the bottom of that. And again, you can see the bottom. I encourage you to go into the Wick Science Building and in the basement, and you can see how much different the Pacific Ocean is compared to all the other oceans. And then there was even a continent that got sucked in. This is Zealandia. The sunken 8th continent reveals buried secrets. What secrets did it have? They found evidence of land-based fossils. So at one time, that land was above the ocean, and then it got sucked in. And Walt Brown predicted they'd find granite in the Pacific, and that's what they find. And then, so now you got the water that was covering the world, and now the Pacific Ocean drops in, and now all the water's gushing off the continents. And it's cutting the submarine canyons. And these are canyons that are below the ocean. You can't cut them today. There's not enough current down there. But you go from the Amazon and the Congo and the Hudson and the Ganges, they all have these submarine canyons, and some of them are longer than Grand Canyon. How in the world did that happen? Well, the continents were higher at that time. The water was gushing off. The continents have sunk in, and the oceans have risen up and buried them in water. And then you got a canyon under 2 kilometers of ice in Greenland. I mean, how does that happen? How do you cut a canyon under 2 miles of ice? Well, the same thing. The water gushed off the continent, and then the Ice Age came. And we'll get into that. And you got the same thing at Lake Vostok. This is in Antarctica. They got liquid lakes under 2 miles of ice. And again, how do you get that? Oh, and by the way, I don't know if you heard of this. This was 2017. There's 91 new volcanoes beneath Antarctica's ice. So if they're freaking out over Antarctica's ice melting, it might be one of these volcanoes. And again, that's what I like, is get all the information so you can make an informed decision. And I encourage everybody to listen or read Inconvenient Facts by Gregory Wrightstone, or at least hear him interviewed on Real Science Radio, rsr.org. And his main premise is, hey, carbon dioxide is not a pollutant, it's plant food. If we had more carbon dioxide in the atmosphere, we'd have more food and less droughts. And he goes on to document, and also go into co2science.org and see the studies that they've done that actually show this. And so again, get all the information to come to your own conclusions. And then this is Epoch Times. The era of unquestioned and unchallenged climate change claims is over. Good. You know, let's have some questions. Like, where are you getting the data? And it even impacted Bill Gates. Fortune magazine, or Fortune, it says, this is September 20th of 2023, so just a couple months old. Bill Gates sees a lot of climate exaggeration out there. The climate's not the end of the planet, so the planet's going to be fine. Okay? And I've always been waiting for an accurate prediction as far as the climate goes. Back in the 70s, they were predicting an ice age. You know, a new ice age coming by 2020 or 2030, new ice age by 2070. Space satellites show new ice age coming fast. And it's always, 10 or 20 years down the road, we have to make these huge changes. And I'm just like, wait, hold on, hold your horses. Let's make an accurate prediction first before we change everything. All right, so how do you get the ice age? The ice age is, and this is interesting, when I saw it, it's hard to find a picture of the ice age, but you notice in the upper left here, there's no glacier in parts of Alaska. Did you notice that? How in the world can you have permafrost today and no glaciers when there's an ice age? That's a hard one. And what caused the ice age? And once it started, why did it stop? Okay, so now an ice age is counterintuitive. To get an ice age, you need warmer oceans, so you get a lot of precipitation, but yet you need cooler summers, so the snow doesn't melt. So warmer oceans, that the hydroplate can explain that, but how do you get cooler summers? Walt Brown says the continents were higher, therefore cooler. Every 1,000 feet, it's 3 degrees cooler. But also there was a lot of volcanoes going on at that time. And so you got a lot of aerosols in the atmosphere. And here's a volcano from 1813. In New England, they had the year without summer. This is from Mount Tambora in Indonesia. They had snowstorms in New England in June, and ice formed on the lakes in July. And this is just one volcano. Could you imagine thousands of volcanoes all around the world going off? How much aerosol would be reflecting the sun's heat? And so the Ice Age, it took probably 400 or 500 years of it melting or snowing more than it melts, and then you get the Ice Age all over, except for parts of Alaska. How come parts of Alaska didn't have the Ice Age? Because it came down as rain there, not snow. And same things in Siberia, too. Oh, and my cousin, he went to Pensacola Christian College, and his roommate was from Inuvik, Alaska, in Inuvik Northwest Territory. It was above the North Arctic Circle. And I said, hey, Norman, how do you guys run your pipes? We run our pipes in the ground so they don't freeze. Your ground is frozen. How do you run yours? And he said, well, we have these things called utilidors. You drive under them or drive over them. They're heated pipes. And it's dark a lot up there, or light a lot, but that's where he is now. Okay, so that's how the Ice Age started. How come it stopped? Well, over those 400 or 500 years of it snowing more than it melts, the ocean is cooling off. Therefore, there's less precipitation. And also, the atmosphere is clearing up. So there's more heat getting down to the earth, and it's melting more of the snow. And so you've got 400 or 500 years to make the Ice Age, and 100 or 200 years for it to melt. And we're still recovering from it to a certain extent right now. And then up at north by the Arctic Circle, we find these frozen mammoths. You know, I think there was like 500,000 tons that have come out of there of ivory. So there's a lot of mammoths that got buried and that got frozen. And one of them was standing up. This is in a museum in St. Petersburg, Russia. And it was frozen standing up. Do we have any hunters out there? Anybody? No? Okay, and this still had identifiable food in his stomach. So it had to be flash frozen, like 150 degrees below zero, like right now. And it wasn't, and mammoths, woolly mammoths is a misnomer. It's not wool, it's hair. They're hairy mammoths. They eat too much, they drink too much. There's no way they can live in the Arctic. They're temperate animals. I mean, your nose gets cold in the winter, just think it was 6 feet long. An elephant is not going to last up in the Arctic. I don't care how much hair you put on it. And so they were in temperate climate. So then the question is, okay, how did it get so cold so fast during late summer? Because they could tell by the stomach the food that was in its stomach. And that brings us to the cold hail. See, some of that stuff was shooting up from the fountains of the Great Deep with such tremendous force that it escaped our atmosphere. And then it got super cold in that cold outer space. And some of this, again, is frozen carbon dioxide, which would be dry ice, and water, which would be ice, and mud. It got up there, got super cold, then gravity took hold of it, and it came slamming down on the mammoths and buried them in this frozen mud, buried them to the ground, and then the flood went over them. Excuse me. Okay, so that's how it got so cold so fast. Well, how come they didn't thaw out if they're temperate animals? Well, that brings us to the big roll. Okay, see, the mountains on the northern hemisphere and the southern hemisphere pretty much cancel out, except for the Himalayas. That's what that orange dot is. That's lead. And it's a big mass on a spinning object, so that's going to try and get to the side. And that means that stuff that as it's going to the side is going to bring stuff from the side up to the top. So the stuff that's onto the top went onto the side, and the stuff that's on the side went up to the top. And that's how you get Mammothville, where there's a lot of food, a lot of water. Mammoths are fat and sassy, moving up to Mammoth Chill, where they never thawed out. Okay, now if that happened, it also brought a lot of stuff up north of the Arctic Circle that can't live there today. In the permafrost, you're not going to get a badger or a shrew or a snake or a turtle or a redwood tree. But it didn't grow there. The Earth rolled it up there. And the same thing with Antarctica. They say the South Pole is mostly covered by ice, but fossils show that crocodiles, dinosaurs, and palm trees once lived on the land. Well, I think the same thing happened. You had tropical palm trees, and it rolled that down to Antarctica. And did it leave a mark on the Earth? And again, yes, it's the 90 East Ridge. See, our equator has a bulge. And as the Earth rolled through that bulge, it ripped. And that's why you have the 90 East Ridge, which is almost straight up and down, pointed directly at, you guessed it, the Himalayas. And so I think the Himalayas were probably 3,000 miles north, farther north than where they are now. And it just shifted the whole world, or the world that much. Okay, now we come to Grand Canyon answers. You can do a whole talk just on this. And these are on my YouTube channel or on the Hydroblade Conference things. That's what happened. One of our videos that we were showing on the Hydroblade Conference, the sound didn't work. And so I jumped in and did the Grand Canyon's answers talk. And somebody was really excited about it today. He's been posting it on YouTube and other places. But why is there a Grand Canyon there and not everywhere in the world? I mean, rivers have been flowing just as long, just everywhere. Well, no, you needed to have the Colorado Plateau with a lot of potential energy. You have these two huge lakes, Grand Lake and Hopi Lake. They got enough water for 3 Great Lakes. And to give you the size of that, if you went to Grand Junction, Colorado, that lake would be 1,000 feet deep right there. And Page, Arizona, it'd be 1,400 feet. And if you went to Farmington, New Mexico, it'd be 350 feet deep. These are huge, huge lakes. A mile in the air. So there's tremendous potential energy. And Hopi Lake's not as deep quite as much, but it's higher. It's 275 feet higher. And you got Tuba City would be 1,000 feet deep. Winslow would be 1,000 feet. And the key to the whole thing is the funnel. The funnel. Once you see it, you can't unsee it. This is Marble Canyon we're looking at. And you got those 2 cliffs. One's Echo Cliff and one's Vermilion Cliff. And that was all connected at one time. That was holding back Grand Lake. And when Grand Lake went over the top, it washed away the sediment until it hit the hard Kaibab limestone, and then it spread out and it made the funnel. And so then there's nothing pushing down on that Kaibab limestone, so it bulges and then it cracks. And that crack leads it to undercut the Hopi Lake. So now you got 2 huge lakes draining catastrophically, and it's just sheet eroding everything above the Kaibab limestone, and now there's nothing pushing down on that whole area. So what forms? The Kaibab Plateau. It rises up, again, it bulges, and it cracks, and the river runs through the crack. Cuts out the Grand Canyon, moves 800 cubic miles of sediment, and then, so there's nothing pushing down in the middle of the Grand Canyon, so what happens? It bulges, and it cracks. That's how you get the inner gorge. That's why the river goes through this hard crystalline rock instead of getting wider in the softer sedimentary rock. Bulging and cracking, that's the key to Grand Canyon. It bulged and cracked 3 different times. All right, okay, and so what caused these inland seas to form? That's like the Mediterranean and the Gulf of Mexico and the Black Sea and the Caspian Sea. We're going to answer a few questions with this one. How do you fuse past iron? That's one of the 11 greatest unanswered questions of physics. And it says, how did the heavy elements from iron to uranium, how were those made? This is from Science of 2002. We're all made of star stuff. The Big Bang created hydrogen, helium, and a little bit of lithium and other light atoms, but everything else, the carbon, oxygen, and almost 100 other elements that make up animals, plants, and Earth itself, was made by stars. The problem is that physicists aren't quite sure how stars did it. See, it works up until iron, and then they have a hard problem. And I think the answer to that is granite. Granite's made of quartz, feldspar, mica, and hornblende. And there can have different amounts of quartz depending on the granite. But quartz is piezoelectric. Piezo meaning pressure and electric meaning spark. So if you squish it or you stretch it, it's going to make a spark. And that's what's going to happen. It's in tension on top and compression at the bottom. It's making sparks. And that's what those 60-mile plates were doing. They called it fluttering, because it's going to slam down on the water, and then the pressure is going to build up, and then it's going to get released, and it's going to go back up and down. And there was one guy who said, that's a big problem for this theory because that does not happen. It does not spark in granite. Well, he must not have heard about the Smithsonian. Why do lights sometimes appear during an earthquake? Or Live Science, mysterious flashing earthquake lights may be explained. Or NOVA, what causes eerie earthquake lights? Nature, earthquake lights linked to rift zones. And electric phenomena in reefs and bizarre earthquake lights finally explained. And I think it's the granite. And again, this is the fluttering. It's going to get pressure, and then it's going to shoot up and get released, and then it's going to slam down again. And all the while, that granite's getting compressed and stretched. And that's how you get those heavier elements made. And because the supernova capability, and this is above my head. If you're very interested in this, go into YouTube, Brian Nickel, The Origin of Radioactivity. And he explains this really well. So a supernova can get up to iron, but then it's a problem. But if you Z-pinch something, you can get all the elements and more. And you do that in nuclear fusion. So you take pure copper and you hit it with a hot dot. I think it's a stream of electrons, if I understand right. And it makes all the 94 natural elements and super heavy elements. And that's what Walt Brown is like, well, hey, if everything was very good, is it good to have radioactive material in the earth that could cause birth defects? And so he thinks that the radioactive material was made during this eruption phase and the compression phase. And so it's going to make all those elements, and then they're going to decay into the valley of stability. And this plasma, that's what happens when there's lightning. I think the electrons are sheared off from the neutrons, and there's plasma that hits the ground, and the air expands and contracts. And so you have this big thunderclast. Boom. Well, a similar thing happens in granite, but it's not a thunderclast, but it does pack the things together, and then they decay. And that's why you find radioactive material mainly on the surface. If the radioactive material came from just randomly from outer space, it should be all through the crust. But it's mainly on the surface, on the continents. And so it's something to think about. Okay, and so that made, with all that radioactivity going on, you're going to have it's going to get hotter on parts of the crust, and then it's going to have too much pressure, and it's just going to explode out of there. That's how you get the inland seas. The Gulf of Mexico, the Mediterranean, the Black, the Caspian. And then with all these neutrons flowing around also, you're going to have make deuterium. See, deuterium is a proton, an electron, and a neutron. Hydrogen is a proton and an electron. So where do all these extra neutrons come from? And the comets have twice as much deuterium as the comets, which shouldn't be, because the theory says we got our water from the comets. Well, then it should have the same amount of deuterium in it, but it doesn't. And I think that half of the ocean at the beginning probably didn't have any deuterium. And then after the flood, it diluted half of it. Just my thought, just shooting from the hip there. And then again, some of the stuff shot up with such tremendous force that not only did it escape our atmosphere, it escaped our gravitational pull and kept on going. So now you got ice and mud and dry ice going through, and it's like dirty snowballs going through our atmosphere. Anybody ever heard of what a dirty snowball, what's been described as a dirty snowball in our solar system? Anybody heard? What's that? Comets, bingo, that's right. And what do we find in comets? And asteroids and meteors and interstellar dust? We find water, salts, silicates, crystalline silicates, limestone, clay, cubonite, olivine, iron, nickel, organic amino acids, bacteria, cellulose, all this stuff from Earth. We find it in the comets. And again, cubonite has to be formed in scalding hot water. How do you get scalding hot water everywhere else in the solar system? We got these rounded boulders on Comet 67P. That's a hard one, because if things smash together in outer space, it's going to have jagged edges. We find rounded edges. How did that happen? Well, the only way you get that is if it's going through a fast flow of water, breaking off the sharp edges before it gets shot into space. And we also find asteroids with moons, which is incredible. To get a moon is nearly impossible. I mean, they can't even explain our own moon. There's 4 different theories, meaning none of them works. One guy said, well, it's observational error. It doesn't exist. But it does exist. Because the thing to capture a moon, either they're going to slam into each other or they're going to slingshot around each other. It has to be almost perfect for them to gather a moon. And yet Florence has 2 moons. Well, how'd that happen? And also you got these peanut-shaped asteroids. And this is a major mystery, how 2 objects, each the size of skyscrapers, could collide without blowing each other to smithereens. This is especially puzzling in a region of the solar system where the gravitational forces would normally involve collision speeds of 4,500 miles an hour. And yet they come together gently like a leaf on the ground. How does that happen? Because normally, I mean, anybody ever play pool? Do those things stick together? No, they break apart. The only way you get them to stick together is if they're all going in the same direction at pretty much the same speed, and then they come together gently. And that's how you can get the moons. That's how you can get the peanut-shaped asteroids. And let's see, and you got comet. And this is a tough one too. The short period comets, those are every 100 years you see them. Okay, and if they came from the Oort cloud, it should be 50-50 mix. Some go in the Earth's direction, prograde, and some going backwards, retrograde. But it's not. It's 93% going in direction of the Earth and 7% going backwards. And so just think of the Earth as a train going 100 miles an hour, and you shoot something off at 50 miles an hour. Well, even if you shoot it straight back, it's still going to go in the direction of the Earth. That's what happened. Those comets got shot out with not much velocity. And the midterm periods, these are 1 to 700 years. It's a little better. That's 70 to 30 mix. And just think of the Earth's still going 100 miles an hour, and they get shot off with more velocity. That's 150 miles per hour. So you're going to get more of that 70-30 mix. And then for the really long period of times, this is if you shoot it off at 500 miles an hour. It doesn't matter which direction you shoot it, it's going to go in that direction. And that's how you get, and that's more of a 50-50 mix. And that's what's up with Naiku. Object's weird orbit puzzles scientists. Again, their Big Bang cannot answer a lot of problems. And so it should be discarded, I believe. Beyond Neptune, a chunk of ice is orbiting the sun in the wrong direction. No, it's only the wrong direction if your whole theory is based on blind chance and random collisions of atoms. If you're using this theory, it makes perfect sense. And it says, this is from a professor at Harvard Smithsonian Center, the orbit of Naiku is unusual in that it is nearly perpendicular to the plane of the solar system. More than that, it is orbiting in the opposite direction of most solar system bodies. Furthermore, there are a few bodies that share the same orbital plane, with some orbiting prograde and some orbiting retrograde. That was unexpected. That's because you're using the wrong theory. And you also find water erosion on Mars. And there's no liquid water on Mars. How does this happen? Well, some of the water from the Earth hit Mars, and it soaked into the ground and froze. And then an asteroid later, or meteoroid, comes later and melts it, causes heat, melts it, and then it goes down. And that's how you get the water erosion on Mars. And people will say, well, Brian, if this really happened, wouldn't it leave a mark on the moon? And I would say, absolutely, it did. Because the moon, and the far side of the moon is way different than the near side of the moon. There's a lot more lava flows and moonquakes on the near side, not the far side. That's what all that dark stuff is. Those are lava flows. Why are they on the near side and not the far side? And you take a look at it, it looks like the near side's been shot with buckshot, and the far side's been peppered. And that's very counterintuitive because the Earth protects the near side. The stuff should hit the Earth if it's coming in from the left, and if you throw in the Earth's gravitational force, it's coming from up and down, it should hit the Earth. And yet that's very counterintuitive, but it makes perfect sense with this theory. Plus, they found the Earth's oldest rock was found on the moon. That moon must just be covered with rocks from the Earth because they're there, they pick up a rock, they bring it home, it's from the Earth. And it goes on to say the rock crystallized about 20 kilometers beneath Earth's surface. 20 kilometers, that's about 12 miles. That would go along with this theory. It really would. And let's talk about some accurate predictions before we wrap up here. And okay, so predictions are the currency of science. And this theory has been making predictions, and it came about in the 70s. And I'm so frustrated that we haven't been banging this drum for the last few decades. They predicted pooled water under mountains, deep channels under the Bosporus and Gibraltar, salt on Mars, asteroids are flying rock piles. NASA ignored that one. Rocks on asteroids and comets are rounded. Water is inside large asteroids. Planet X will not be found by January 2021. And carbon-14 in old bones. And there was also one, they predicted olivine in the comets, and he was right. And I was talking to the professor that had this book for 6 months, and she said, I don't believe the water was under the oceans back then. And my response is, why not? There's water under the oceans today. You got these black smokers where there's super hot water coming up from beneath the ocean. Well, water has to be there below that, and it shouldn't be. You know, granite's maximum strength is 2,300 psi, and then it turns to putty. And it's going to seal all the cracks. So there shouldn't be any water below 5 miles, and yet that's what they did. Germany cut a hole 5.7 miles. Russia cut a hole 7.6, and what'd they find? Crushed granite and water, just like this prediction would have said. And some people will say, well, the problem with this theory is that it would have gotten too hot it would have boiled the oceans, it would have gotten too hot for the atmosphere, and it would have just blown the crust off. Well, they're not realizing that this is directed energy. I mean, that flame is 1,800 degrees, and his hands are right next to it. And air is a great insulator. And so this is all directed energy. It's like, hey, there's so much energy on that rocket, it should have blown that Saturn rocket to smithereens instead of sending them to the moon. No, it's directed energy. It's controlled. And the Joule-Thomson effect shows how things cool off as they expand. And I think you'll enjoy this one.
Would I dare to take this glove away? Yeah, easy. Easy city, man. No problem. Hot or cold? Begin with a C. It's cool. Relatively cool. HC. I'm not going to put it way down at the nozzle. It turns out that that which you are seeing here, gang, is not steam. That which you can't see, that's the steam. But what does that steam do? Begin with the X. Expand. And when it expands, what's it do? Begin with another C. Cool. And there's your evidence of it right there. Isn't that remarkable?
Isn't that amazing? So it could have been shooting out with tremendous force and cooling off, and it's not going to fry everything. And to wrap it up here, I'm going to give you these. I'll have these at the end. If you want more information on this, go into hydroplate.org. Otherwise, rsr.org. That's Real Science Radio. And you can go into /HPT or /answers, and I'll show you what you find there. And if you like YouTube, go into Brian Nichol. He does a great job of making this, illustrating it, if you want to see it. His videos are second to none, especially his Grand Canyon video. And then I try and make the best of it with Solidify Your Faith. So again, here's Brian Nichol. He talks about the origin of radioactivity, comets, the 90 East Ridge, limestone, Grand Canyon. A lot of problems for the secularists. And you go into rsr.org/HPT, and you're going to be able to get the 9th edition for free. Just scroll down to see this book, and then it's going to have a 9th edition button, and you can download it for free. And I encourage you to download it. Have it at your fingertips, because the internet can be taken down at any time. And on that website, you're going to hear interviews. You're going to learn more and more and more about this theory. And then also at the bottom, there's going to be a Walt Brown controversy. Why haven't you heard about it in all these decades? See, I used to be motivated to get this out there to give Walt Brown the credit he deserves. And now I'm motivated to get this out there into the mainstream before NASA makes another catastrophic blunder. And I've been into the science departments 4 times, the president's office, the dean's office over at the community college, and nobody's interested in getting these answers. And that's very stunning to me. It's very puzzling. If there was a theory that could explain all these answers, wouldn't they just be banging down the doors to get them? And to be fair, maybe they're going into the website. Hopefully they are. And hopefully you'll be able to discuss this in class. And then you can go into rsr.org/answers, where you're going to see published criticisms of this theory. Also YouTube criticisms of this theory. So you're going to have all the information to make your own conclusion. Don't you wish every theory would do that? And then you're going to have answers to the objections. And wouldn't it be neat if the Big Bang would list all the criticisms and evolution would list all the criticisms? Because we should have multiple working hypotheses if we want science to advance. So then you have all the information, so you come to your own conclusion, and then you'll be able to, but now that's not happening. And I go to St. Cloud State, I'm in their free speech zone, see what a poster thief wanted censored, and that had some good conversations. And they also had, will SCSU lead us out of the dark ages of the blind chance and random collisions of atoms dogma? Will they? I hope so. Will you be able to talk about this in class? Will SCSU allow the hydroplate theory to be discussed or remain in the dark ages? And so I encourage you to bring up this theory. Again, I've been into the science departments 4 times, and it's just stunning that people don't want the answers. And so again, here you are, hydroplate.org, rsr.org, and YouTube. And I'll just leave that there. We're at 9 o'clock, right on the money. If you guys need to go, you can go. Otherwise, we'll do some Q&A. There was a lot of information all at once. Anybody have any questions, comments, concerns? SCSU students, can you bring up a theory like this in class? Would you be allowed to talk about intelligent design or creation? Or would you have to think about Big Bang and evolution, blind chance and random collisions of atoms? Do you have the freedom to think and discuss ideas? Or I've talked to the students, it's like, no, we can't do that here. Which is sad, because my tax money should be going to higher education. And that's where all these ideas should be able to be discussed. And if they're not being allowed to discuss, it's not higher education, it's higher indoctrination. There's a government view that they want to teach, and even if there's a better theory, they aren't going to let it be discussed. But hopefully you can. Well, thank you so much for coming. Again, more of my talks are on YouTube, Solidify Your Faith. And there, I did have an encouragement. I go to a lot of different colleges. And I was at this one college, and a student invited me to class. I thought he was inviting me to a club, and I went there, and the professor was there, and he said, "Oh, I heard you're coming. Come on in." And he gave me 15 minutes to talk. And I talked about being able to see both sides and how things are being censored, and you need to see both sides. And I was done in 10 minutes, and he said, and I said, "Any Q&A?" And he goes, "Well, what would you do if you ran the science department?" And I said, we'd put all the theories on the table, and we'd focus on the theory that makes accurate predictions. And I also said we wouldn't teach belief systems about the past. That's not science. We're going to deal with observation and testing. How do you get a man to the moon? How the moon got there is irrelevant. A heart surgeon doesn't need to know how the heart got there. He needs to know his anatomy. And then a student asked, "Well, do you believe in God or science?" And I said, "I believe in both. The Bible and science go hand in glove. The Bible and evolution bang heads because evolution's not science as far as observation and testing." And then another student said, "Isn't it sad that that question even came up?" And I said, "Yeah, it is, but I understand why it came up, because people are not being taught where we got science from. The who's who of science, Newton and Maxwell and Faraday and Boyle, Pascal, they were all creationists, and yet students aren't being taught that." And then I told them about Matthew Murray. In Psalm 8:8, it said, God said there was paths in the sea. And he thought, well, if God says there's paths in the sea, I'm going to go find them. And he found the ocean currents. And it saves the shipping industry billions because he looked at the Bible and he went after it. He figured it out. And then George Washington Carver, they gave him 10 minutes to speak in front of Congress for the importance of the peanut in the Southern economy. And he was so interesting, they let him go for 2 hours. And the guy said, "How'd you learn so much about the peanut?" He said, "An old book." He said, "What old book?" He said, "The Bible." He said, "The Bible tells you about the peanut?" And he goes, No. The Bible tells me about the one who made the peanut. I asked him what to do with it. And I told that class, just think if we had the freedom to think like that with our technology, what we could do. But we can't think down that path. We're limited in this government-imposed box of blind chance and random collisions of atoms. And it's turning the Big Bang into a laughing stock. And so I encourage people to, if you're gonna have to educate yourself. Don't expect to get educated in class because you're not going to get all the information. Hopefully they'll allow it. Students should be able to bring it up. And with that, I'll get off my my soapbox. Thank you all for coming. One last chance? Any other questions? Well, again, thank you so much. I appreciate it.